Hello everyone. I want to do a quick walkthrough of our week 4 lab where you will be writing code that will decrypt an encrypted method. Now, if you have no experience with encryption, it'll sound daunting, but I've already written the encryption method for you and I've written most of the inputs for you, so there's really only one section of the code that you will have to modify. So let's run the solution. And what we're going to do is encrypt a message. Hello. And what we see here is my plain text message, hello. My encrypted message, HKUUM. And my decrypted message, where I took HKUUM and decrypted it to hello again. This is the part of the code you'll be writing. This encrypted to decrypted. So you're going to decrypt the message back to plain text. So let's talk about substitution ciphers. And let me make this a little bigger. So, in your reading this week, the first time we're using this other Python text, it talks about what a substitution cipher is. And a substitution cipher is a very simple form of encryption which replaces a single letter with another letter. So in this case, you have an alphabet A through Z, and each of those are unique characters, and you're substituting it with the character in the same position as the key. So when we talk about strings this week, if we look at our alphabet, A is in position 0, index 0, B is in index 1, C is in index 2, all the way to Z in index 25. The key is essentially each letter of the alphabet scrambled, and you replace the letter of the alphabet you find in a string with the corresponding index of the letter in key. So if we have a plain text message and you find a lowercase a, you replace it with Z because both are in index 0. If you find a Z in the plain text string, you replace it with an S because they're both in index 25. That's how encryption works in the substitution method. Decryption is backwards. If you get an encrypted string and you see a Z, replace it with A. If you see a J, replace it with B because those are both at index 1. If you see an S, replace it with Z because they're both in index 25. So let's jump down to our inputs first. So we saw on the screen input type a message to encrypt. This is where we're just accepting the input from the user. And I'm calling two methods. First, we're encrypting the message with the key, and then we're decrypting the message with the key, and then we print it all to the screen. All you will be working on this week is what's inside of decrypt message. Well, let's go to encrypt message first, because it's going to be, hint, hint, very similar. And also watch the last video on string methods this week to learn about the find method, because that's going to be important for decrypting. So let's see how to encrypt the string. And just an FYI, your code is the reverse of this. So when you encrypt, you do the reverse to decrypt. So the function encrypt message, it encrypts a message using a key and outputs ciphertext. The parameters are the plain text, so that's what the user entered, and the key. And we talked about the key up here is the alternate alphabet that we're using. So we start off by creating a placeholder variable called ciphertext. This will hold our encrypted message. So remember we typed in hello, and it's going to be important because there were two items in that string that weren't in our alphabet, an uppercase H and a parentheses. So that's part of your spec for this week, is you ignore characters that you're not encrypting. So first we iterate through each character in the plain text message. So if you remember, we talked about for loops. You can treat strings like they are lists. So for each character in the string, we ask, okay, where in our alphabet is this character? What index? Now, just so you know, Python will return -1, and I've written this here for you. Python will return -1 if it is not found. So, for instance, capital H will not be found. A space will not be found. An exclamation point will not be found. So if we do find it, so let's say it is found, we add to the ciphertext the value in key at the index of the corresponding item in alphabet. So if it's an A, it's index 0. What's index 0 of the key? And so on and so forth. If the character wasn't found, it's obviously not in our alphabet, so just add the character as is to the string. So if you notice, our encrypted version of hello still had a capital H and still had an exclamation point. We did not encrypt those characters. Once you've iterated through all of the characters, we return the ciphertext, or the encrypted text. The decrypt message is the reverse. You're going to get ciphertexting, you're going to decrypt it. So I've started this for you. I've created a placeholder called plaintext that will store the decrypted value, and I've already returned the value for it. Your job this week is to figure out what to put here. So, hint, it's the reverse of encryption, and I'm not talking back to front. So even though you still iterate through the string like you did in encrypt, but think about, instead of going from alphabet to key, where are we going? We want to go backwards. So I will tell you, your solution for this week will be 5 lines of code. So this is almost a whodunit, investigative style lab. I've done all the heavy lifting for you. Now it's your part to figure out the piece of the puzzle that is here. So some things to remember. Number 1, you want to use find. I talked about find in the video. I talked about find here within the encrypt method, or encrypt message function. If you found a corresponding index, it returns the index. If it doesn't find anything, it returns -1. Use that to your advantage. Use the fact that strings you can treat like lists. You can iterate through them in a for loop as you would a list. You can access items by index as you would list items. Use that to your advantage. And again, test with multiple messages. So you saw here I used a capital H and an exclamation point. If I just had hello, this would translate all the characters because all of the letters are in my alphabet. Translate my name here. If I knew how to spell my name. Whoa. There we go. Asgg. That would be my name. And I translate it back to Matt. So I hope you have fun this week with the lab. Like I said, it's not a lot of code. You just have to think about what encryption is. This is probably your first time encountering encryption. Remember, the whole goal of encryption, and you'll read about it this week in the text, it's to hide messages from prying eyes. It's confidentiality. If you take more cybersecurity courses, you're going to learn about the CIA triad. And confidentiality is one of the key ingredients in that, because you want to make sure messages are only read by the person who is intended to read it. So that is extremely important when you're considering cybersecurity. So again, keep that in mind. It's less about integrity and availability, but more about making sure that prying eyes cannot see what you're doing. So, again, have fun. If you have questions, shoot me an email. Don't wait until the end of the week to do this. And I hope you have a good week. Thanks.